Alrighty, welcome back. We are still on activity 26. This is our part 2, and we're getting into special cases for factoring. So activity 27 focuses really on the meat and potatoes of factoring, of how to go from a trinomial to two binomials. And we're going to kind of talk about this here as well, but I'm going to go over specific special cases. The first one is perfect square trinomials. So if you don't remember what a perfect square trinomial is, basically if I take a binomial and square it, I get a specific pattern for a perfect square trinomial. So let's look at that. So let's look what happens when I multiply two of the same thing. So if I were to multiply these, x times x gives me x squared. 3 times 3 gives me 9. Okay? So we have our first term in each factor is x. Our second term in each factor is 3. So let's see what happens if I do x minus 3 times x minus 3. So if I multiply x and x is x squared. X times negative 3 is negative 3x. X times negative 3 is negative 3x. So see, I have two of the same thing. And negative 3 times negative 3 is positive 9. So when I combine my like terms, I end up with x squared. Combine those, I get negative 6x plus 9. So here, x squared minus 6x plus 9. So let's look. So let's just see what we notice. These two things look exactly the same, except the middle term is positive, the middle term is negative. Here, when I look, I have two negatives. So my first term in each factor is x. My second term in each factor is negative 3. All right. Let's see what happens with x plus 4 and x minus 4. Okay, or x plus 4 times x plus 4. So x times x is x squared. Notice that every time I'm multiplying, I've got x times x, x times x, x times x, x times x. So I'm going to end up having x squared every single time. So let's put that in. Up to this point. Then we have a b's and a minus b's. Okay, x times 4 is 4x, and then this x times this 4 is also 4x. So notice I'm getting the two of the same thing, and it's because I'm squaring. I'm multiplying x plus 4 and x plus 4, so I have to multiply x times 4 2 times. So that's kind of important. And then I have 4 times 4 is 16. So when I combine these, I get x squared, plus 8x plus 16, because I've got to combine those. So plus 8x plus 16. Now here, this has a negative in it. So if we remember from this pattern, these ended up being exactly the same except with a negative sign. So I would assume, and we can do the math if you don't believe me, but here I would assume that I would have a negative 8x here, just following that basic pattern structure. And let's go ahead and fill in our first terms. And here our second term was positive 4, and our second term was negative 4. And we can go ahead and fill this in as well with plus 5 and minus 5. Okay? So just thinking about our pattern so far, I am taking I'm multiplying and getting x squared each time. The last term, if I were to multiply, I'm going to have to do 5 times 5, which is going to give me 25. So now it's just the middle term we have to figure out. So let's think about it. Let's go ahead and multiply to the side. And we know, so we know we're going to multiply x and x to get x squared. We know we're going to multiply 5 and 5 to get 25. And we know that these are going to be two of the same thing. So we're going to have to do x times 5, which is 5x, x times 5, which is 5x. Add those together and get 10x. And here, if it's negative, that would, if we change these to negative, that's going to change these signs to negative, which is going to make this a negative 10x. All right, so we should start to see a pattern, but for those people who don't, I also think it's just worthwhile to do it. We're going to use a and b instead of numbers just to see what happens. So our factors are now a and b, and a and negative b. So let's multiply a and b and see what happens. A times a is a squared. A times b is ab. A times b is ab. And b times b is b squared. So, my first term ends up being a squared. Plus, I have two of these ab's. So 2ab plus b squared. And we can assume it's going to follow the same pattern. And if it's a negative, or an a minus b, we'll have a negative ab. Or negative 2ab. I was about to say ab squared. Okay, so when we have two of the same factors, so remember, these are two of the same factors. We're squaring it. So whenever we square a binomial, we're going to have the first term squared. We're going to have the second term squared. And then the middle term is going to be 2 times a times b, because we did a times b twice. So our pattern is a plus b squared equals a squared plus 2ab plus b squared. Excuse me. So this should be our pattern that we follow. So when we factor, if we notice that we have an a squared and a b squared, and that the middle term is double a and b, that we should be able to factor it into two of the same thing. Okay, so let's answer some of these questions. So what do you notice about the relationship between the first term of the polynomial and the two factors? So if I look at the first term of the polynomials, it's always x squared or a squared. It's always the first term squared, or the first factor squared. First term of the factor. So the first term of the polynomial equals first term of the factor squared. Okay? What do you notice about the relationship between the last term of the polynomial and the two factors? Well, the last term of the polynomial is that b squared. So it's the last term of the factor, the second term of the factor squared. So the last term of the polynomial is equal to the second term of the factor squared. Okay, what do you notice about the middle term? So the middle term of the polynomial is equal to the product of the two terms of the factors doubled. So you take the two terms, a and b, multiply them, and then multiply them by 2. Okay. Alright, and then number 9, factor the following perfect square trinomial. So we know that it's a perfect square trinomial. So let's think about this. We're going to have two binomials. So let's look. The first term is x squared, which means the first term of each binomial should be x. Then this last term is 49. So what's the square root of 49? Well, that should be 7. All right, let's look at this middle term. This middle term is negative 14x. So in order for me to get this, I would have to do x times 7 plus x times 7. So that'd be 7x plus 7x, which would give me 14x. But this is negative, which means that both of these terms have to be negative. So the factored form of this equation, or this polynomial, I'm sorry, the factored form of this polynomial is x minus 7 times x minus 7, or x minus 7 squared. Okay. So let's say you want to double check that. Remember, it's like doing the backwards distributive property. If I were to multiply these, I should get this back. So this is my answer. It looks like a problem, but our problem looks like an answer. So this is our answer. Let's double check it. Let's just multiply to the side and make sure. The way we check this is if I multiply these two binomials and get my problem back out, that means that this is correct. So we'll multiply. X times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is negative 7x. Negative 7 times negative 7 is positive 49. If I combine my like terms, I get x squared minus 14x plus 49, which was our problem. So this is our answer. Okay, so let's turn the page. And we have one more special type of factoring, and that's called a difference of two squares. So number 10 asks us to basically go backwards. We're not factoring, we're multiplying. And the reason we're doing that is if we practice multiplying and notice this pattern, we should be able to go backwards from it. So I want you to notice, let's look at these factors real quick. What do you notice about factor 1 and factor 2? They're almost the same with the exception of the sign in between them is different. So we have x plus 3 times x minus 3, x plus 4 times x minus 4, x minus 5 times x plus 5, so on and so forth. Alright, so let's just start multiplying and see what happens. So we'll do x plus 4 here, x minus 4 here. So x times x is x squared. X times 4 is 4x. X times negative 4 is negative 4x. Negative 4 times positive 4 is negative 16. So let's combine our like terms and see what happens. We're left with x squared. Now 4x and negative 4x cancel out. And then we just have minus 16. Let's look at this real quick, because this is actually incorrect. And I think I remember that from the first time I made this. So I don't have my up-to-date version. This actually should be x squared minus 9. Should be the answer here. X squared minus 9. I think I got copy and paste happy when I made my worksheet. Okay, so let's look at the next one. We have x minus 5 times x plus 5. X times x is x squared. Negative 5 and x is negative 5x. Positive 5 and x is 5x. 5 and negative 5 is negative 25. So we have x squared. Negative 5x and 5x cancel, and we're left with negative 25. So what are you noticing as we go through? Do I have a middle term in any of these? What's happening when I multiply? Well, I've got a positive and negative of the same thing, so they end up canceling each other out. Also, If I look at the first term, I've got x times x. That's x squared. If I look at the second term, I've got 4 and negative 4. Multiply those, you get negative 16. There's no middle term. It's the first term squared and the second term squared. And because you've got a positive and negative, the middle term cancels out. So when we do this, you should get 81 minus x squared, 4x squared minus 49. And then I'll do a and b over here because I think that's worthwhile. A plus b and a minus b. So a times a is a squared. A times b is ab. A times negative b is negative ab. And b times negative b is negative b squared. So no matter what numbers you have, that ab should cancel out. That middle term should always cancel out. So you should have a squared minus b squared. All right, so let's answer some of these questions. Number 11, what do you notice about the relationship between the first term of the polynomial and the two factors? Well, the first term of the polynomial is always the first term of the two factors multiplied. But since the first term is the same, it's squared. So we're going to say first term of the polynomial equals first term of factors squared. Okay, what about the last term and the two factors? Well, it should be just like this. These two answers should be just like the one on the first page. So what else do we know? The last term of the polynomial is equal to the second term of the factors squared. Okay, what do you notice about the relationship between the middle term or lack thereof of the two factors? So because we have a positive AB and a negative AB, the middle term is always canceled out or 0. We could say there's a middle term of 0, but that really just doesn't help us. So, but that's basically what it is. It's negative AB and positive AB equals 0. So our middle term technically is 0, but we don't need to write that, so it cancels itself out. All right, in 14, factor the following difference of two squares, x squared minus 121. So again, when we factor, we should have two binomials. And since this is a difference of squares, we know that the first term is the first term squared, so we have x. X squared can be factored into x and x. And then 121, well, what's the square root of 121? And that should be 11. Now, if these were both positive or both negative, I should have a middle term. But since I don't, that means that one of these terms is positive, one of these factors is positive, and the other factor is negative. Okay, so this should be my answer. Now let's double check it. Let's multiply it out and make sure that it works. So let's go to the side and multiply x plus 11 and x minus 11. And x times x is x squared. X times 11 is 11x. X times negative 11 is negative 11x. And 11 times negative 11 is negative 121. And then these 11x's cancel because one's positive and one's negative, and you're left with x squared minus 121, which is the problem we were given. So that answer is correct. Okay, so this is where I'm going to leave you guys. Hopefully that has helped you out some. If you have any questions, feel free to email your teacher or drop a question in the comments. And I hope that this was helpful, and I hope to hear from y'all soon. You guys have a great day.